I have analyzed the past 10 physics semester papers to give you the concepts and questions that are essential for you to not fail the Physics 2 or Physics AP exam. I get it. There's not enough time for you to go through the entire lecture notes and the physics textbook for you to study for your exam, which is coming up in a few days. So what I have done is that I have collected a few essential concepts and questions that are really important that have come frequently over the past semester exams so that you only need to learn them so as to not fail. So take out your notes and your pen and let's get started. Let's start off with a question from section 30.4, the RL circuit. An RL circuit with L equals to 3 Henry and an RC circuit with C equals to 3 microfarads have the same time constant. How long will it take to charge the capacitor in the RC circuit to 60% of its maximum value? We have our options given from A to E, and let's begin. From reading this question, what we can find out is that L equals to 3 Henries, the capacitance equals to 3 microfarads, and that the capacitor is charging. To find, we have to find the time until the charge of the capacitance is 60% of its initial charge, or its maximum charge. The needed equations are the time constants for the capacitor, the time constants for the inductor, and the charge equation. Let's proceed with the solution. We have both the time constants of the RC circuit and the RL circuit are same, so RC equals to L divided by R, which leads to R square equals to L over C. Rearranging, we get R resistance equals to square root of 1000, which is 31.62 ohms. Next, we use the charge equation and plug in the value of Q as 0.6, which is 60% of the maximum charge. Into the equation, Q0 and Q0 get cancelled. We have 0.6 equals to 1 minus e raised to negative t over 31.62 times 3 times 10 raised to minus 3. We rearrange the equations and solve for t, and we get t equals to 0.87 seconds. The next question is from Faraday's Law, section 29.2. For this section, I choose this question from a past paper. Magnetic induction. To determine the strength B of a uniform magnetic field in his laboratory, an engineer uses a solenoid, a long magnetic coil of radius r with n windings, rotating it at an angular frequency omega equals to 2 pi f about an axis perpendicular to the magnetic field and to the symmetry axis along the solenoid. He detects an induced EMF with a maximum value of epsilon. The magnetic field strength is, and then we have options from A to F. So first, reading this question, we are given that angular frequency and we're given EMF, and we are required to find the magnitude of magnetic field. The needed equations for this problem is magnetic flux equals to BA cos theta, and we can convert this further into BA cos omega t. And we have EMF is negative derivative of magnetic flux. We further find out the derivative of that equation, which is essentially finding the derivative of cos omega t, and we get BA omega sine omega t. The negative gets cancelled. EMF, if you look at the term A, which is the area, it is nothing but pi r square. But we also have n windings, so we have to multiply that with n times because we can assume that there are n coils. So we have EMF equals to n omega b pi r square sine omega t. After we rearrange the equation, we get B equals to epsilon over n pi r square omega. Next, we delve into electric potential from section 23.2. For this section, I choose problem 13 of the past paper, which has 6 points. The potential in a region of space can be described by the function v of x equals to 12x squared plus 23x minus 77. What is the electric field vector E at position x equals to negative 3? And then we have options from A to E. Reading this question, we are given the potential equation V of x equals to 12x squared plus 23x minus 77. We are required to find the electric field E at x equals to negative 3. The needed equations for this question: E equals to negative derivative of the potential, which is equal to minus 24x plus 23. At x equals to negative 3, we just plug in the value of x, we get E equals to 49x. Notice that 49 is positive, and it cancels out the negative in the equation, so we are left with option A. Electric field and electric forces, section 21.4. For this section, I really like this problem that I found in the past exams. What is the magnitude of the net force that acts on a particle with charge q equals to 0.5 coulomb at the instant when it has a velocity vector v equals to 1000 x cap at a location in space with a magnetic field b equals to 0.25 x cap minus 0.25 y cap and an electric field E equals to 450 y cap minus 800 z cap? All vectors are given in SI units. And then we have the options from A to E. Reading this question, we are given that Q charge equals to 0.5 coulombs. The velocity V equals 1000 x cap, and magnetic field B equals to 0.25 x cap minus 0.25 y cap. And we also have the electric field, which is E equals to 450 y cap and minus 800 z cap. We are required to find the magnitude of the force. The needed equations are here. We can see that the force is due to the electric field as well as the magnetic field. We calculate them individually. Force due to electric field, we have the charge times the electric field, which is 0.5 bracket 450 y cap minus 800 z cap, and we get, after we multiply, we get this. Force due to magnetic field is V cross B, which is a matrix, which is a determinant of V and B. After we find out and calculate the determinant of the given matrix, we find it is equal to minus 250 k cap. Force due to the magnetic field is Q times V cross B, which if you solve, you get minus 125 k cap, because you're multiplying it with the charge. The total force is the addition of electric field force and the magnetic field force, and we get the sum to be 225 y cap minus 525 z cap. To find the magnitude, we square root of this individual component square. We get an approximate value of 571, which is option D. We're now going to solve this next question from Application of Gauss's Law from section 22.4. Two uniformly charged solid spheres of total charge minus q and q with radius r are placed along the x-axis with centers at x equals to 0 and x equals to 2r respectively. The electric field produced by both charged sphere at x equals to r over 2 is, and then we're given options from A to F, along with the figure. Reading this question, we are given that the spheres have minus q and plus q charged, and their radii is r, and that they are both uniformly charged. We are required to find electric field at x equals to r over 2 at x-axis. Needed equations are E equals to kq over r square and E equals to kqr over r cube. They're both equations for electric field outside the sphere and inside the sphere. The total electric field is the sum of the electric fields of both the spheres, E1 and E2. We plug into the equations, and then we finally, after solving them, we get E equals to minus kq over r square, with square brackets, half plus 4 over 9, which is option D. And finally, we're going to solve this question from section 31.3, which is the LRC series circuit with an alternating source voltage. Consider a series RLC circuit with R equals to 60 ohms, L equals to 0.4 Henry, and capacitance equals to 4 times 10 raised to negative 4 farads. The AC source has a voltage amplitude of 90 volts and an angular frequency of 240 radians per second. Note, you do not have to punch these numbers into your calculator to get full credit. Please indicate the algebraic expressions that you intend to evaluate for each question below with the numbers in the expression. Part A. Find the impedance of the circuit. Part B. What is the maximum current that flows in this circuit? And Part C. What is the phase angle between the current and the voltage supply? Reading this question, we are given that the resistance is 60 ohms, the inductance is 0.4 Henry, and the capacitance is 4 times 10 raised to negative 4 farads. The potential or the voltage is 90 volts and the angular frequency is 240 radians per second. To find the first part is impedance, the second part is the maximum current, and the third part is the phase angle. The equations needed to solve is Z, I max, and tan phi. Solution. For the first part, Z equals to the square root, and then you plug in the numbers into the equation. For the second part, I max, you get V max over R, which is 1.5 amperes. And the third part, tan phi equals to XL minus XC divided by XR, which is L omega minus 1 over C omega divided by R. And then you get the answer by taking the tan inverse, which is 54.97 degrees. With this, I believe that you're adequately prepared to not fail the Physics 2 or the AP Physics C exam, Electricity and Magnetism. I encourage you to watch the upcoming video where I will be explaining the concepts of each of these sections so you can understand it better.